Hello everyone, so we will start the new topic which is the Gauss law from the chapter electric charges and field. This is a very important topic for the CBSE board students which is in class 12. So let's begin this topic by the Gauss law topic. So Gauss theorem. What is statement of that? The total electric flux through any closed surface is equals to 1 by epsilon naught times of the net enclosed charge or charge enclosed by that surface. So the first word came in our mind, that is, what is the mean of electric flux? In the previous topic, I explained in the briefly that what is electric flux. But in here, I just want to elaborate little bit that net electric field lines passing through any closed surface defines the term electric. That means electric field lines, if these are the electric field lines, if this will pass to any particular surface area, so the remaining, which is the outcoming electric field lines, we will call as a flux phi. So the phi will be comes vector E dot S. This will be, we will studied in the earlier topics. So this phi is equals to 1 by epsilon naught times the net charge enclosed. Net charge enclosed means the total charge. Clear? That means epsilon naught is the permittivity of a free space. If closed a surface S encloses the charge Q, then according to the Gauss theorem, phi is equals to 1 by epsilon naught times Q enclosed. By definition, total electric flux through a closed surface S is given by phi is equals to closed integration vector E dot vector ds. So Gauss law proof. Consider a point charge Q inside a closed surface A as shown in this diagram. So imagine a sphere B of a radius small r with the charge small q at in the center of the sphere. Electric field at any point on the surface of the sphere B is given by 1 by 4 pi epsilon naught q by r squared. This is the first equation. Now I'm supposing this will be the flux which is passing through the ds surface. So d phi is equals to vector E dot vector ds. This is the second equation. What we have to do, firstly we saw this particular diagram in a complete way. This is a diagram where ds is a surface closed by this Gaussian surface. The Gaussian surface, this is a Gaussian surface actually. This is a Gaussian surface. The main role player member of this Gaussian surface defines that charge must be bound. So if we have to bound the charges, we need a packed surface. Like if we have to if we have to make the boundaries of our home, so what we are doing? If we want to save something that can't be destroyed, so we just create a boundary in the form of a wall for our home. Similarly, we just create a boundary in the charges, around the charges also. We just say that particular boundary is told as a Gaussian surface. What surface? That is a Gaussian surface. Hope I'm clear. Moving ahead, so substitute 1 in equation 2, d phi we will get 1 by 4 pi epsilon naught q by r square ds. This d phi is an elementary flux which is passed by, or field lines pass through elementary surface. So basically this surface is a very elementary, very small. Because of that, the electric field lines also, which is the outcoming, that is a small. So we are taking as a d phi and ds the term. For total flux, what we are doing, just integrate this term. Integration of a d phi is equals to integration of 1 by 4 pi epsilon naught q by r square ds. We know that integration of a ds will give the phi. Integration of a d phi will give the phi. So 1 by 4 pi epsilon naught q by r square s. Now the value of a surface area for a sphere is a 4 pi r square. So 4 pi will be cancelled out each other and with the r square also. The result we will get phi is equals to q by epsilon naught. Uses. simplifying electric field calculation where there is a symmetrically or symmetricity in charge distribution. It is used to find total flux associated by the closed surface also. By applying the Gauss law, we can solve always easily way that find out the electric intensity due to the various kind of a nature of the charges distribution. Let's see few questions so that we can see or we can think that which topics we have learned actually have we understood or not in a clear way. So in a Gauss theorem, the total electric flux over a closed surface is equals to dash 0, 1 by epsilon naught times the charge enclosed within the surface, product of enclosed charges, none of above. What was the correct answer? The correct answer for this question is a B. The Gauss theorem told that net electric flux phi over a closed surface is equals to 1 by epsilon naught times the charge enclosed within the surface. Application of a Gauss theorem. So in the application of a Gauss law, we have some symmetric charges configuration. However, it is possible to obtain electric field in a simple way by using Gauss law. Clear? One thing which is a keep in mind, like a Gauss law is applicable for the symmetric charge distribution or symmetric charge configuration. So this is applicable for symmetric charge configuration. So field to an infinitely long straight uniformly charged wire. Okay, this will be. So for starting to solve this question, firstly we have to consider an infinitely long thin straight wire with uniform linear charge density lambda. Okay, so this is a particular infinitesimally long wire which have a positively charged. There will be a point P where we have to calculate this electric field at this location. So as we know that electric field lines are radially outward for each section, so this will be formed an sphere. And for making bound this particular surface, we need a surface which is enclosing these charges that we will call as a Gaussian surface. So this will be called as a Gaussian surface over there. The wire is obviously an axis of a symmetry, as you can see. So the point P, P prime, P double prime so obtained the completely equivalent with respect to the charge of the wire. This implies that electric field must have a same magnitude at these points. The direction of electric field at every point must be radial outward if lambda is greater than 0 and inward is lambda is less than 0. That means greater than 0 means if the charge is a positive, so field lines will be radially outward. If the charge is a negative, so this will be inward. Now consider a pair of line elements like P1 and P2 of the wire as shown. So in the electric field is everywhere radial in the plane cutting of the wire normally, and its magnitude depends only on the radial distance small r. To calculate this field, imagine a cylindrical Gaussian surface as shown in the below. So we have a packed surface which we call as a what? Yes, this will be Gaussian surface. So since the field is everywhere radial, flux through two flat surfaces of the cylindrical Gaussian surface is 0. At cylindrical part of the surface, E is normal to the surface at every point and it is parallel to any area vector on the curved surface. So the net flux will be 0. The surface area of the curved path is 2 pi RL, where lambda is equals to Q by L. So Q is a charge where L is the length of the cylinder. Flux through the Gaussian surface will be flux through the curved cylindrical part. So E is equals to E into 2 pi RL. The curved surface enclosed and net charge, which is Q is equals to lambda L. We just put this value and get the formula of E, which is the E is equals to lambda by 2 pi epsilon naught R. Vectorially, we can say that E is equals to lambda by 2 pi epsilon naught R n cap. So n cap is showing the direction here, okay, and the direction is what? Radially outward. So when n cap is a radial unit vector normal to the wire passing through the point, E is directed towards or outwards if lambda is a positive, inward if lambda is negative. It can be negative or positive. Also note that through only the charge enclosed by the surface lambda L was included above, the electric field E due to the charge entire wire. Further, the assumption that wire is infinitely long is crucial. Without this assumption, we cannot take E to be normal to the curved path of the cylindrical Gaussian surface. So, we have a different types of questions in which the first one is the electric field intensity at a point due to the line charge distribution at a distance r is directly proportional to 1 by r square or 1 by r square. Electric field intensity at a point due to the line charge distribution at the distance r. So the correct answer for this question is a 1 by r. Next, we have a long wire carries a charge of 210 to the power minus 8 centimeter. Find the electric field at a distance of 0.2 meter from it. So, the value of A is equals to 1800 volt per meter. The B option is 1850 volt per meter. C option 2000 volt per meter. And the D is 1750 volt per meter. So let's see the correct answer for that. That is the A option 1800. For solution, lambda is given here 210 to the power minus 8 centimeter. R is given 0.2 meter. So we use the formula E is equals to lambda by 2 pi epsilon naught R. Put all these values here and we get the result. Hope you understand this question solution. So move ahead with this new topic, electric field due to a uniformly charged infinite plane sheet. Electric field due to uniformly charged infinite plane sheet. Let sigma be the uniform surface charge density of infinite plane sheet. We take x-axis normal to the given plane. By symmetry, the electric field will not depend on y and z coordinate and its direction. We can take Gaussian surface to be rectangular, parallelepiped of cross-sectional area A as shown in this diagram. Okay, so a cylindrical surface will also same do. As seen from the figure, only two faces 1 and 2 will contribute to the flux. Electric field lines are parallel to the other faces, therefore do not contribute the flux. The unit vector normal to the surface 1 is in the negative x direction, while the unit vector normal to the surface 2 is in the positive x direction. Therefore, E dot delta S through the both surfaces are equals to add up. Therefore, the net Gaussian surface is 2EA and the charge enclosed by the Gaussian surface is sigma A. Like this will be the particular surface. These both electric field lines are because of that electric field exists. So this will be Y, this will be X. Surface charge density will be sigma. Therefore, by Gauss law, EA is equals to sigma A divided by epsilon naught and E will be get sigma by 2 epsilon naught. Vectorically, if I'm just saying E is equals to sigma by 2 epsilon naught n cap, where n cap is a unit vector normal to the plane sheet and in the outward direction, and E directed away from the plate if sigma is positive and towards the plate if sigma is negative. I just want to elaborate few things more over there. The electric field, as we can see here because of this side, so if we just want to calculate the net pi. So this will be close integration. This will be the for x plus x e dot ds plus this will be for the negative x minus because of that ds plus one field lines should be making from perpendicular from this. So this will be again a substance section 90 which is in the z direction vector e dot vector ds. So in this case the angle will be 0. In this case the angle will be 180 and this case the angle will be 0. This is the angle 90. So this scenario E S because ES only because cos 0 will be 1. So the answer will come only ES. Again cos 180 will be minus 1 and minus minus plus. So this will becomes ES again. And plus cos 90 will be 0. So the final answer will become ES or we can write opposite to EA. Hope I am clear why this term to EA came in the nature, which we will solve. So let's start with the MCQ question. The first is the electric field intensity at a point due to uniformly charged infinite plane sheet is directly proportional to the distance of the point from the plane sheet. The B inversely proportional. C independent of the distance. D directly proportional to the square of a distance. The correct answer is C independent the distance between the point from the plane sheet. Second, we have for a uniformly charged plane sheet, the electric intensity at a point is sigma by 2 epsilon naught, sigma square by 2 epsilon naught, 2 sigma 2 epsilon naught by sigma, or none of these. The correct answer for this question is option A. Electric field due to a charged spherical shell. So for a charged spherical shell, firstly we have to consider a spherical shell which has have a radius capital R and the charge is small q. So because of that, at point P location, we have to find that what is the electric field at the center of the cell. Surface charge density sigma by A. So sigma is equals to Q by A. So Q is equals to sigma into 4 pi r square because the value of A is 4 pi r square for a sphere. Where P point is outside of the cell. For this scenario, we make an Gaussian surface from this. So, if the field lines inside the conductor, this will be for a hollow conductor. Electric field will be 0. After that, electric field will be constant in this scenario. And then electric field, firstly, because of the reason increases, but the electric field will be decreased after a particular, because the value of R increase, so the value of E decrease. From this formula also. So total electric flux will be, firstly we just see the electric field 1 by 4 pi epsilon naught q by r square. Variation of E with R for a spherical shell of charge. So consider a Gaussian surface of a R radius. The total flux through the surface phi is equals to E. Closed integration ds. The value of closed integration ds is a 4 pi r square. So E into 4 pi r square is equals to Q by epsilon naught. That means the value of E comes this. When the P point is on the surface, then R is equals to capital R and we get formula like E is equals to epsilon form. So E is equals to Q by 4 pi epsilon naught R square. E is equals to sigma divided by epsilon naught, where sigma is equals to Q by A and Q by 4 pi R square. When P point is inside the cell, R is less than R. Consider a spherical Gaussian surface where R is less than R. In this case, Gaussian surface does not enclose any charge, hence according to the Gauss law, this is a particular spherical Gaussian surface. This is the ds. So field inside the spherical shell is 0 because there will be no charge. So E into 4 pi r square is equals to 0 divided by epsilon naught. That means E is equals to 0. Let's see some master's question MCQ. The total electric flux through a Gaussian surface when P point inside the spherical shell is given by The correct answer for this question is A option. The total density through a surface when point P is on the surface R is equals to capital R is given by 0, sigma, Q by epsilon naught or sigma by epsilon naught. So the correct answer for this question is option D. So this is all for today's. Thank you for watching this video.